Hello, very good evening. My name is Samir Kumar Singh, and today we will discuss the week 7 tutorial. The main motive of this tutorial it will help you out to solve the question of week 7 assignments. Okay, so question number 1 is on your screen. Please try to solve it. And the question is the given channel coherence time and coherence bandwidth are 16 microsecond and 16 kilohertz respectively. 16 QAM modulation are used for the communication to achieve 1 Mbps throughput. Which of the following is true about the channel? So the coherence bandwidth and coherence time and coherence bandwidth is given. We are using a 16 QAM modulation schemes and we want to achieve 1 Mbps throughput. So you have to tell which option is correct. Basically, you have to tell about the channel. Channel is a channel following the slow fading or fast fading, or it's frequency selective or frequency flat. So using this information, try to calculate, and you can comment your answer. So please use this data. You can comment. Again, I am repeating this question. Question is that given channel coherence time and the coherence bandwidth are the 16 microsecond and 16 kilohertz respectively. 16 QAM modulations are used for communication to achieve 1 Mbps throughput. Which of the following is true about the channel? Okay, now we'll see the explanation. After that, you can comment. Okay, basically what is given, coherence time and coherence bandwidth is given, and that okay. By using this, we can calculate our symbol duration. The symbol duration is that Ts is equal to 1 upon Rs, and basically we are using the 16 QM modulation, so we can calculate the symbol rate by using this. So it will become exactly 4 microsecond. Okay, if we compare the hours of symbol duration with the coherence time, so our coherence time is greater, coherence time is 16 and coherence symbol duration is 4. Whenever our coherence time is greater than the symbol duration, then it mostly follow the slow fading nature. The channel is our slow fading. Okay, so according to this A and C maybe are correct, but by using this we can check, because we have to also check this is a frequency selective or following the flat fading. Okay, so next our signal symbol rate we can get from there. It's coming at 250 kilohertz and the coherence bandwidth is the 100 kilohertz. Okay, so our signal bandwidth is greater than the coherence bandwidth, so it is a frequency selective channel. If it is less than that, so it will be the flat fading. So option A is the right. The part is the right answer. Okay, next question number 2 is on your screen. Question is that which of the following statement is true for the interference limited system? That given that C is the carrier power and is the noise power and I the interference. Basically, there is the formula is given. C is the two ratio is given, and ratio it is a ratio of the signal power and noise power. It is the ratio of signal power upon interference power. So you have to tell which statement is the true. Sorry, which option is the true? So from using by the intuition, you can comment. Basically, if you know the which power, if you have a noise power interference, which is a dominant. If you know that, you can comment your answer, because signal power is a constant for the both. So please try this. Just use the concept of the signal power or noise power and interference power, and put those value. or you can comment which option is the correct. Okay, the right answer of this question is the 2B. Okay, basically if you talk about the noise power and interference power, basically interference is always the dominant in most of cases. If you compare high interference and noise power, so our always interference will become the high. Okay, so we compare this to the question number statement 1. So noise power is always close to this ratio will be high because interference is high, so this ratio will low. So statement 1 is the true. Next, we're talking about the next statement. Here you are adding the 1 plus noise, but in the okay, and there is an interference. So in this case, statement number 2 is the false. So B part is the right answer because interference limiting system I is mostly greater than the N. So B part is the right answer. Next question is the question number 3 is that given that maximum Doppler shift in a channel is 100 Hz, it is required to simulate a channel using Jack's model with 50 oscillators. Which of the following is not an oscillator frequency? The options are rounded up to the 2 decimal values. So try this question. Again, I am repeating this question. Question is that given the maximum Doppler shift in a channel is 100 Hz, it is required to simulate the channel using Jack's model with 50 oscillators. Which of the following is not an oscillator frequency? Please try this. Okay. To solve this question, we have to know what is the Jack model. Okay. So explanation of this question is is front of the screen. Okay. According to Jack model, we want 50 oscillator. Okay. It is required to simulate a channel using Jack's model with 50 oscillator. So it is equal to n naught plus 1 is equal to 50 oscillator. So preobserved oscillation frequency is given by Fn is equal to Ft cos 2 pi n upon 4n naught plus 2. Okay. So here n is varying from the 1 to n naught. So from there you will get Fn naught plus 1 is the 100 Hz. Okay. So you can observe all options A, B, C. Okay. A, B, C are the 100, 99, B is the 99.95, C is the 99.80. Okay. So when you observe, so F50, F1, F1 and F2, D doesn't correspond to the oscillator frequency. You can find with these equations. So D is the right option. Okay. This option is not considered. Okay. This is wrong for the recordings. Next question is on your screen. Question is the which of the following is the drawback of the Smith methods? As I discussed the Smith method using those concepts. Please let me know which option is the correct. You have to tell the drawbacks of the Smith method. You can comment your option, your answer. Again, I am reading this question. Question is which of the following is a drawback of the Smith methods? Just think about that and revise your concept and try to answer this question. Okay. So first option is the long pulse response. B is the different filter need to be designed for the each Doppler shift. Third is the non-flexible in terms of length of fading waveform. Fourth is the all of them. Okay. Okay. These are all the drawbacks that has been got in the Smith models, Smith methods. Okay. So this all option is the right. So the solution of the question number 4 is the D part. Okay. Question number 5 is on your screen. Question number 5 is consider a base station and a mobile system with two antennas. Okay. There is a scenario is given. There is a one base station and a mobile system that having a two antennas. Okay. The transmission from the base station is picked up by the both the antenna. Okay. Whatever base station is transmitting, bases. Okay. Mobile antennas, both antennas is getting this, which experience different channel conditions and has different value of instantaneous NR. Okay, the channel condition is different for the both antennas. So whatever you will get, so generally we calculate the instantaneous SNR. So at the antenna end, we are getting the different values on the both antenna. So the SNR for the both antennas below the threshold at which the signal can be properly detected. The main point is given that the SNR for both antennas below the threshold at which the signal can be properly detected. So the meaning of this line is that whatever we are getting, it is a little bit, it is a low with the our threshold values. So by using that we can't detect our signal properly. Okay. So what is asking? The question the which of the following diversity techniques may lead to proper detection of the signals? So you have to tell which option is the right. We whatever by using which diversity technique we can properly detect our signal. The first option is the selection diversity. Second is the optimal diversity. C is the both A and B, and then D is the none of the above. Okay. So by to apply the concept of selection diversity and optimal diversity, check it and let me know which is the true. By using which concept we can detect our signal. Scenario is simple. We have base station and mobile system which having two antennas. Both antenna is receiving our signal, and both have a different channel condition and getting different values. Condition is that both sessions are as the lower than the threshold value. So which of the following that diversity technique may leads to proper detection of the signals? So please try. Okay, now we'll see the explanation of this question. So firstly we will discuss the selection diversity and optimal diversity, whatever we do into both condition. After that we will check which option is true. Okay. So according to the scenario, let gamma 1 and gamma 2 be the SNR and the two antennas of the mobile system. Okay. We are getting gamma 1 and gamma 2. Mobile, such that gamma 1 is the less than the gamma threshold and similarly gamma 2 is the less than the gamma threshold. Okay. What is gamma threshold? Gamma threshold is the threshold for the proper selection detection. So according to the selection diversity, if you have two values, so we select the maximum SNR, maximum of them. So here we are getting gamma 1, gamma 2, and we will take the max. So it will be gamma 1 and gamma 2. But okay, and similarly in the optimal diversity, here we will add the both values. Okay, so gamma 1, gamma 2. Here we will add them. So in the optimal diversity we will add them, and the selection diversity we will take the maximum of them. So as you know that condition is given that gamma 1 and gamma 2 both are the less than the gamma threshold. So in the selection diversity, we always less than the gamma threshold. So we will never detect our signal by using the selection diversity. Where gamma optimum diversity may be greater than the gamma threshold, because here we are adding the both values. Maybe there is chance it will be go up to the gamma threshold. So by using the optimum diversity, we can detect our signal. So there is a chance that optimal diversity may lead to the proper signal detection. Okay. So B part is the right answer. The option was the selection diversity. It was wrong. Optimal diversity is the right, and both A and B, because A is the wrong. So C option is also wrong. None of them, but B, the higher chance we can detect our signal by using the optimal diversity. So B part is the right. Okay. Question number 6 is related to the previous question. Okay, question number 6 is that in the previous question, assume that one antenna experiences SNR above the required threshold while other does not. Which of the following diversity techniques will lead to proper detection of the signal in the case? Okay, so please let me know. Yeah, concept is the same here. But condition is different. Okay, again I am repeating this question. Question is that in the previous question, assume that one antenna experience SNR above the required threshold. Okay, so from one antenna getting the more than a threshold value, while other doesn't not. Second is the same as previous, but but the first antenna is getting the more than threshold value. So which of the following diversity techniques will lead to the proper detection of the signal data? So you have to tell which option is true. For this condition, we also apply the selection diversity and optimal diversity. So try the previous concept and you can comment your answer. Okay. So in this case, gamma 1 is the, according to given conditions, gamma 1 is the greater than a gamma threshold and gamma 2 is the less than the gamma threshold. Okay. Whenever we apply the selection diversity, we will choose the maximum value. Okay. So gamma 1 is the greater than gamma threshold and gamma 2 is the less than the gamma threshold. Whenever we take the maximum value, it will pick gamma 1 and gamma 1 is the greater than the gamma threshold. So by using the selection diversity, we can detect our signal properly. Okay. Now we'll check the optimal diversity. In optimal diversity, we will sum the both value, and here gamma 1 is already is the greater than gamma threshold. Whenever you add the second value, it will become greater than a gamma threshold. So by using the optimal diversity, we also can detect our signal. So in this condition, both has the true. So option C is the right answer. Okay. Question number 6, which we will choose option C. Okay, question number 7 is on your screen. Please read it and try to answer these questions. Okay, question is that compute the probability that output SNR of a selection diversity scheme is the 15 dB lower than the average SNR of each branch when using the 3 receiver antennas. Okay, so we are using the concept of selection diversity. Already we discussed it. So compute the probability that output SNR of a selection diversity system is 15 dB lower than the average SNR of each branch using 3 receiver. Yeah, here we have a 3 receiver antennas. So we and all antenna are getting the some values, and so we have to tell the probability that output SNR of a selection diversity scheme is 15 dB lower than the average SNR. Apply the previous concepts into the mathematics and try to comment this answer. So explanation of this question is there. Okay, so we have 3 receiver antenna. Okay, so what is the gamma threshold according to condition, we are getting the SNR less than the 15 dB. So gamma T threshold is equal to the gamma minus 15 dB. Okay, it is in dB, you can convert in the linear scales, so it will become 10 to the power minus 1.5. So we have to calculate the probability. Here we using the selection diversity technique. So gamma selection probability of gamma selection is less than the gamma threshold. Just put it will come in this form, and m is the one number of receivers. So just put the value. Already we calculated the gamma ratio. Already calculated this ratio, and it is that 10 to the power minus 1.5. M is the 3. Whenever you will solve, it will become 3.0 into 10 to minus 5. Okay. So D part is the right answer. next question is on your screen. Question is the consider the BPSK symbols are sent from the transmitter and the 4 antenna receiver is deployed. Okay, we are a transmitter and we are using BPSK symbol. We are sending the BPSK symbols, and and our receiver end we deployed the 4 antennas. If only one antenna used, it has performance of the probability of error 3.87 into 10 raised to minus 7 in AWGN channel. Okay, whenever only one antenna is used, we are getting the probability of error is for the AWGN channel. Now, if all the 4 antenna are used for the selection diversity in the relay feeding channel, now scenario is changed. All 4 antennas are active and receiving the, and we are using selection diversity techniques. But channel is changed here where we are using the relay feeding. So, what will be the outage probability given the minimum SNR required for the successful reception is the 3 dB. So calculate what will be the outage probability given the minimum SNR required for the successful reception is the 3 dB. Okay, try this. Use the first condition. Next, by using them, try to calculate outage probability. For the first condition, we are using an AWGN channel, and the second we are using the relay scenario. Please let me know which option is correct. Okay, and this is the explanation of this question. Okay, firstly we are using the AWGN channel. The formula of the probability of error for the AWGN channel Q in the root 2 times of the SNR. Okay, so gamma is given, probability of error is given 3.87 into 10 to minus 7. So we just put the probability of error. From there we can calculate the gamma WGN using a Q inverse. By using a Q calculator, you will get you will calculate 10 gamma WGN. It will become approximately 10. Okay. Now scenario change. We are using a relay feeding scenario. Okay. So for this we calculate the average SNR, and it is the formula for this scenario. It's the E of the Z square into gamma WGN. You can write this. You can write this term in 2 parts. Okay, and gamma WGN is 10. From there you can calculate that this value is coming 1. Okay, so this now we have to calculate the outage and gamma for the selection diversity. To get the outage, it should be less than the gamma TH. Okay, so here we have 4 receiver antenna. Already we see this in the last question. Just substitute the values. Okay, and from there you will get your answer. Okay, so sorry, so for this question we solve the right. Now question number 9 is on the screen. The question is that consider the case where co-phasing is implemented using 4 receiving and receiver antenna. Assume that average SNR of each antenna is the same and given by the gamma. What is the average SNR of the signal obtained by the co-phasing? Okay, here we are using a co-phasing concept of co-phasing. Question is that consider the case where the co-phasing is implemented using 4 receiver antenna. Similar to the previous question, there are also we have a 4 receiver antenna, but we are using the co-phasing. Assume that average SNR of each antenna is the same, and just given right all we are getting the average SNR is the gamma from the all antennas. Now, what is the average SNR of signal obtained by the co-phasing? When you apply the co-phasing on this scenario, so you have to tell which change. You have to tell what will be the gamma. So after the co-phasing, your gamma will be changed with these values. You have to choose. You have to tell which option is the correct. Okay. So try this question on your notebook, and you can comment your answer. Let's please try this. Simply, question is the, I think question is clear. Here we are applying the coefficient, so you will tell the what will be the value of this after applying the coefficient concept. Okay, this is the explanation of this question. Here we are using the coefficient concept, and this is the derivation. Okay. And we are here we have a 4 receiver antenna, so value of the n is the 4. Okay, so the received signal after the cophasing can be written as this. RT is the receiving signal, this is the noise, and ST is the signal. Okay, so its summation is going from the 1 to n, where n is equal to 4. Here we multiply with the e power minus j phi 1 zi into st plus eta it. Okay. Okay, here zi is the consists of two terms. One is the magnitude and the phase, and have the mean 0 and variance 1. All the following the IID complex Gaussian nature. So from there we can calculate the mean value of the this magnitude terms. It will become the 1, and we can calculate the again e zi. It will come. We will get it to 5 under root pi by 2. So here condition is given that when we multiply by zy into zj and calculate that e extraction, it will come pi by 4. But I and j should not equal to. Okay, so from there you calculate these values. Now the received signal is you can write on this way. We have calculated the average SNR. Basically, it's the ratio of the signal power and noise power. So we will take the ratio of the both. This is the magnitude of to calculate the power. You will do the square of this term. Similarly, for the noise term, you will do the square. So when you expand it from I is equal to 1 to n, okay, so it will look like that, and it will become n into sigma n square, and it will be look like this. That is, when we solve it, you already have these both values. Just put these values, and you will get as the 1 plus n minus 1 pi on 4 to gamma. Okay, basically n is the 4, just replace it, so it will become gamma into 1 plus 3 by 4. So this is the derivation of the coefficient concept. Just if you know that, you just replace this value. Okay, so option A is the right. So you can see that when you apply the coefficient, your SNR lands by the 1 by these factors. Okay, next question is a true false question. Question is the detection selection diversity the receiver come before the selection. Just let me know which option which is it is this statement is true or false. Again, I am repeating this question. Detection selection diversity the receivers comes before the selection. So please let me know. It is true or false. Okay, it is the true. So option is the right answer. Next question is that it's also same as the it's the in this question you have to tell which this statement is true or false. Question is cophasing diversity is easier to implement than the selection diversity. Both the concept already discussed in this question, so you have to just tell me which option which is the easier to implement, cophasing diversity or selection diversity. In the both cases, we calculate our gamma. We see the how the SNR changed after applying this diversity schemes. You see also see the derivation of the coefficient diversity. So coefficient diversity easier to persistent is true or false. Selection diversity is easy to implement. So for the 11th question, option A is the false and B is the true. Okay. So these all questions are for the session. Thank you.